Hello, hello. Where did that go? Okay. All right. Good morning, everyone. Sorry, I'm about a minute late. Always fun stuff around here. So we are getting near the end of it. We only have 2 more lectures. So we're going to lecture today, then we're going to lecture Tuesday the 28th, and then that will be it for this course. Remember, that's not saying class is done on the 28th. Class is done on the 30th, but we'll be having our final exam that day. Now, it's not going to be during class necessarily. It's going to be the same as before where it's on your own time, but it is 1 day only. So we'll talk more about that soon. Normal stuff, 6.1 and 6.2, my math lab homeworks are due today, as well as the Excel 5.1 lines. Then 8.1 and 8.3 are due next class, and by 11:59 p.m. per usual, since we covered those last time. The next Excel that you're responsible for is 6.1 fund, and we very briefly went over 1 or 2 details of that, just to make sure everybody gets a good start on that. I didn't want to have anyone pausing, so if you get stalled out on that and you're not watching these lectures, we'll go back and watch the lecture. And I know that seems like a circular argument, because me saying that line is during the lecture. Anyways, project, those should all have been submitted by now. I'm not going to take any late submissions unless you had some extenuating circumstance. I will grade those today or tomorrow. I know I said I was very busy the last couple days, so I will be working on those this afternoon after all my classes are done, and or tomorrow once I get up. So you should see those grades very soon. Your next discussion board is going to be some general finance questions that I'm going to post this evening. Some of these will be open-ended. I might not even have any real math questions here. Again, it's just general finance questions like, should you have credit card debt? Things like that. That some of we'll get into today, some of we may get in the next class, but it'll ultimately be covered. Your next quiz will be in Canvas before 5 p.m. today. That's going to be due on the 28th. This, I don't want to, you know what, I don't want to say that. I'm not going to say this. I think this might be another video quiz style questionnaire where you'll have a spot to download it and then a spot to submit it. I hate that I have to do it that way, but I can't create an assignment that's graded and allows me to upload a document and you to upload a document. It's just like one too many things for Canvas. And I know a couple of you have pointed out, like, hey, Mr. Beckner, there's some spots in my math lab or some spots in Canvas where I see, you know, assignments, but you haven't mentioned it, and it says it's past due, and there's no grade. We're not worrying about any of those things. If for some reason an assignment I've never said is due is a 0, it doesn't get counted that way in my grade books. My grade, I go back and I put every single grade that you have that I assigned into my own personal grade book, and then that's what I use to do your grade calculation at the end of the semester, which is basically what I've suggested you do on your own along the way using an Excel setup. And I even showed you a good Excel setup at the, what was that? Chapters 2.2, somewhere in there. There will be a final exam review for the final exam that's Thursday the 30th, which is 1 day only. That's going to be another 2-hour 20-question test, by the way. You will only get 1 attempt on this, not 2 attempts. Again, for a final exam, I can only do 1 attempt. That will cover chapters 1 through 9. I mentioned that it's going to be a little more heavily weighted chapters 5 through 9, but there will still be a decent amount of questions on chapters 1 through 4. Roughly 33% of them will come from the first half of the course. But again, since we had a major test on all that material, I don't want to have it be as major of a focus for the final exam. So for the chapter 1 through 4 stuff, study the midterm review and the midterm. Go back and look at the midterm review, which was like 60 questions, the midterm itself, which was like 20 questions, because I'll be pulling from those questions pretty much to get you your final exam 30% worth, 33% worth for the material. For chapter 5 through 9, I'm going to give you a new document or a new My Math Lab assignment. I'm still kind of putting that together. So you'll have a notification for that once it is available. I'll send you an email once I have that provided. So regarding this about Friday or Saturday. Again, I want to have everything done by Friday, but I have a lot of little things, so it just might be Saturday, but you'll still have plenty of time with that. And like I said, it could be in Canvas, like the last one was, or I might actually make a My Math Lab assignment out of this one since it'll be a little shorter. Now, it wouldn't be a graded assignment. It would just be for you to practice with, but get a little more feedback. So again, there will be an email going out on Friday or Saturday in regards to that and where it will be. Yeah. All right. So hopefully no questions on any of this stuff. It's kind of crazy to think we're already at the end. I feel like we just started this. I'm sure you feel differently. You might feel like you've been tortured with all these different assignments and me demanding you study 9 hours a week and work 9 hours a week in addition to watching the lectures. But such is life. I hope that we've learned something from this course. I hope you have something to take away, especially on the finance side. That's one of my personal favorite topics to help people. It's kind of cool that we have this QR quantitative reasoning course now, whereas a decade ago, you'd just be learning algebra for the sake of algebra, and you're going to go, well, when am I ever going to use this in my real life? And QR, I teach you how to retire on retire on a Starbucks cup of coffee a day and get $1 million if you're 18. When are you ever going to use that in your life? I hope you get to use that in your life. That is extremely applicable. Or the concept of proportions and being able to just extrapolate very simple data. There are so many ways you can use that in your life, like predicting prices and discounts and such. Okay, so rambling aside, let's get into this. Chapter 9, and actually before we get into this, I want to show you a formula sheet that you're going to find in Canvas now, if it already wasn't available. I think I need to unhide it finally. And this is going to be your finance formula sheet for the final exam. So you're going to want to have a copy of this for your final exam. So print it off and have it next to you, or have it open electronically if you will, but you're not supposed to add anything to this. This is supposed to be it. You're not supposed to put any notes. You're not supposed to put any additional formulas or examples or anything. This is your formula sheet for the final exam. And the first 4 formulas you see should look familiar. How do you calculate a future value when you're compounding interest annually? It's this formula. How do you calculate a future value when you're compounding more than once per year? So the N represents the number of times we compound in a year, typically quarterly or semi-annually, monthly, or daily. And then that R changing to an R over N and the T changing to an NT is a pretty common appearance in a lot of these other formulas, as you'll see. We also discussed this present value needed for a goal compounded in times. So the top 2 are when you need a future value, when you know the starting value and you want to know the future value. So again, I'm gonna write some quick little memos on here. But again, you're not supposed to put them on your formula sheet. Just take your own notes aside from that. And again, that shouldn't be used for the test. So these top 2 are when we know the starting value. This one right here is when we know the ending value. See, the thing that's by itself is what you were supposed to be finding. P represents a starting value, A represents an ending value in the way that I prefer. And yes, we have seen an example where P was an ending value for a formula, and I said I don't like that one. I don't ever use that one, even though it's in the textbook. It's kind of a bad one in my opinion. P should stand for principal. So this one is used for when you know the ending value. Now I want to make an extra note just kind of coupling these 3 things together. These letters are A and P. P stands for a principal, the initial deposit. This is a one-time initial deposit. That's what we like P to represent. So whenever you have an example, whether it's in my math lab or in our course or in the real world, and you just end up needing one of these formulas, you know to go to one of these 3 primarily if it's a one-time deposit. How do you know which one to use from there? Well, it's whether you know the starting value or the ending value, whether you are compounding once or multiple times. And this last formula, if you wanted to compound once, P equals A over 1 plus r raised to the t, and this is for annually. But I don't have that on the formula sheet for two reasons, and you shouldn't add it to the formula sheet, because this right here represents the annual case. And you might say, well, why did you write the top one then? All you really need is this one and this one. And you are exactly right. I really only need to give you these two formulas. The first one really comes from the second one. All you do is you let n be 1, and this thing goes away because anything divided by 1 is itself. And this thing goes away because anything times 1 is itself. And the same can be said of the lower formula. These n's, which is turned to 1's, which disappear essentially. So I do give you the two variations for when you know the starting value, and honestly that's because these are a much more common example, but I do at least give you the ultimate formula for when you know the ending value. So again, this can be used for compounding annually. You just let n be 1 for annually. The APY formula we discussed, that's where if you have an account that compounds more than once per year, what would the effective annual yield or the effective annual interest rate be as if you had only compounded once? That's what this converts between. And remember, I can give you an APR and ask you for an APY, but we can't go the other way because it involves this nth root formula that we're just not going to discuss in here. Now, that's the top four that we have already discussed. The bottom four, we're going to get into today and next class. I'm not sure how many we'll get into today, but we'll definitely get into them by next class. And again, I'm not asking you to memorize any of these. But let's go ahead and discuss the dynamics of these. When we see payment for these top three formulas, so let's talk about all these together. Payment, instead of being a one-time deposit, is a multiple-time deposit. That doesn't change. Now, in the real world, I'm dyslexic there for a second with my spelling. In the real world, you have the ability to deposit whatever amount of money whenever you want to do it. You can deposit $1 today, $5 tomorrow, $1,000 the next day, or you can deposit $100 in January, $5,000 in February, nothing in March, nothing in April because you just put away $5 grand, then another $100 in May. You can do whatever you like. In our course, to be able to actually handle the mathematics, we have to simplify some things. One of the things we have to simplify is we have to make the same payment every single month when we're using these formulas. Now, if we want to use Excel, we can do whatever we want because we can just manually type in the numbers. Or maybe every year we increase our deposit by 2%, which would keep up with inflation, arguably. We could have Excel after 1 year calculate that 2% bump and then deposit it for us. But we can't do that with these core formulas. So again, please understand that if I give you a problem where I'm expecting you to put a bunch of numbers into one of these formulas, the PMT represents the same deposit over and over and over, whether it's 1 year, 5 years, or 50 years. That's the difference of P and PMT. P is a one-time occurrence, a one-time initial deposit or initial borrowing amount. PMT is what you are going to store away every month or every quarter or every year into your retirement account. Now this last formula, the PMT still represents something you're doing over and over and over, but instead of you putting the money into a retirement account, you're taking this money and you're putting it towards a, you guessed it, loan. So specifically and typically car loans and mortgages, but this does apply to any traditional loan that accrues interest on a compounding interval of monthly, daily, whatever. So if you go get a loan for a boat, or you just get a small loan for your student debt, they all use this formula essentially. Now, this bottom formula, I don't give you the compound annually versus compound in times. We only do this compounding in times. So please note that because there are n's in this formula, that is not necessarily just for compounding annually, it's for compounding in times. Now, when I say compounding in times, that also means how often your interest is accruing for these for all these formulas. So for all of these formulas, your interest must accrue at the same interval that your monthly payment or deposit is being made. So this is a super important note, that interest for these formulas will compound at the same rate as a payment is being made. That's for all four of those. So if you are depositing money annually, for the sake of simplicity, your interest has to accrue annually. And in any example you see, that will be the case. I will never give you an example where I say your interest accrues quarterly and your payment is annually, or your interest accrues monthly and your payment is daily, or your interest accrues daily and your payment is monthly. That last one would be the most common scenario, admittedly. But I would never give that to you, because that formula, I quite honestly don't know it off the top of my head, but I do know it is massive. It is insane. You do not want to do that. Yes, it can be done in the real world. Fortunately, Excel can handle it. But when we're just doing this all at once calculation, we don't need all the information in between. We have to deal with these very specific scenarios. So again, top three formulas on this screen right here, these top three, excluding the APY you saw a second ago, these are for something called an annuity. Annuity, annuity, annuity. Now, I've used this word occasionally throughout class, and I did verbally give the definition, but we're going to give the official definition today. In that an annuity, there we go. This is a type of retirement account or a type of savings account. It doesn't have to be retirement, but often it's a retirement account where you deposit money on regular intervals for an amount of time. Now, when we talk about actual retirement accounts in the real world, there are retirement accounts called annuities, and then there's retirement accounts called mutual funds, and then you've got these pension plans. They all fall under the umbrella, mathematically speaking, of being an annuity. But when you go to set up your retirement account through Charles Schwab or Fidelity or Acorns, or Robinhood, or wherever you're going, they're usually not just called annuities. You might be able to find an annuity, but it's not the same thing as what I primarily am going to be discussing with these mutual funds. So mutual funds, you can still calculate your interest and future values and all that jazz with these annuity formulas. But when you look into finance, if you talk to a financial analyst, that person probably might not call it an annuity. Again, they just call it a mutual fund. So when we talk about savings account problems up to now, we've primarily just dealt with single deposits. And again, these formulas are for one-time deposits. When you have the letters P, you use the formulas with the letter P when you have one-time deposit. How can you tell if the problem is going to deposit money once or multiple times? Read the problem. Read it twice, read it 3 times, read it 5 times, whatever you have to do to soak in the information. Okay. So if it says you deposit once, you know you're on one of these 3 formulas. If it says you're going to make multiple deposits, you know you're on one of these 3 formulas. If it uses the word loan anywhere, guess what? You're using this formula. And these are some big beefy formulas that you are going to want to practice with your calculator in your next 9 to 10 hours, on top of studying for the final and everything, which will be, including this stuff. Okay. What was the last thing I wanted to point out? So, value of an annuity compounded annually versus value of an annuity compounded in times. Look at the differences between these formulas. Your R's turn into R over N's. your T's turn into NTs. It's literally the same change as going between these two or going between these two. Now, how does this formula develop? Don't ask. I'm not going to prove it. You don't want to see that proof. We don't have time for that proof. But it is a cool proof. This is actually one of my favorite proofs to do when I finish college, but I'm a sick, twisted mathematician. So take that with a grain of salt. But I love this little finance math where you develop these formulas. Okay, so again, how do you know? All right, well, how do you know whether you should use one of these two formulas? Well, it's based on, are you compounding annually, the top one, or compounding more than once per year, then use the second one. Well, how do you know if you're supposed to use one of these two formulas versus this formula? Well, it's whether you know your deposit or you know what you're ending with. When you know your deposit, when you know your deposit, you're using one of these two formulas because the future value is the unknown. Or if you know what you want to, say, retire with, if you know what you want your future value to be, there's your A, you want to use this formula because your monthly or daily or quarterly or whatever yearly payment is the unknown. The thing by itself should be the unknown. I'm going to say it 2 more times. The thing by itself should be the unknown. Once more, the thing by itself should be the unknown. You have to know every single one of these letters, the A, the R, the N, and the T, there's 4 of them, in order to find the payment. Or if you want to find the future value, you need to know the monthly or annual or whatever payment, the compounding interval N, the interest rate annually R, and the amount of time in years T. Now, these are cookie cutter. They are formulas that you don't have to memorize. So arguably, this shouldn't be difficult. But conceptually, once again, you are going to need to practice this with your own calculators to make sure that you are able to punch in these numbers and get accurate results. Because there's a lot of ways you can mess up. This N times T, remember what we said about exponents. You have to pre-multiply them. There's another scenario going on here. There's an NT, so you'd have to pre-multiply it. Here is a, look at that, negative NT. This is out of these 8 formulas, this is the only one that has a negative exponent. This is the weirdest, wackiest formula of all of them, because depending on your calculator, when you go into your exponent, some of you will have to hit the negative first before you type in whatever that number is, that N times T, whatever that result is. Some of you will actually have to hit the negative after the number, and again, that's depending on your calculator, and I can't possibly pull up 30 or 40 different digital calculators and show you what I mean. So you're going to have to, with these lectures, follow along very carefully and make sure that you can get the numbers that we get. Otherwise, how do you know that you can do the homework right? How do you know that you can do the review right or the final right? Now, I'm not going to put a ton of these on the final exam. This is pretty last minute, especially considering most of these formulas we're going to get into examples next class with. But I will still throw 1 or 2 of them up there for good measure. But what I know is, I know that after this class is done, if you printed this formula sheet, you're probably going to ball it up and throw it in the trash or set it on fire in some glorious ritual. I don't know. And I'm not suggesting that to anyone, especially inside of a building. Again, no suggestions there at all, just trying to guess what some people might be doing. So 5 years from now, when you're going to go get a mortgage and you go, well, what's my payment going to be? What's my monthly payment going to be? And I don't want to ask my mortgage consultant. I want to do this on my own so that maybe I can shop around. So I know you're probably not going to pull out this payment. So what I'm going to do is I'm going to give you some real world experience. I'm going to show you some websites that have some of these calculators built in. Now, one of these calculators is a little different than the formula, what the formula uses. So specifically the annuity formulas, the way that they handle the intervals, their answer is usually off of our answer by just a little bit, but that's okay. Because in the real world, if you're trying to figure out what you'll have to retire with if you put away, say, $200 every month for 40 years, if this formula right here tells you you're going to have $1 million and the online calculator says you're going to have $1,300,000, are you going to cry a river over that $300 error? No, you're not. You're going to go, wow, I'd have $1 million. I need to start working on this. So again, just in the interest of what's the silly term, not silly term, what's the term? Being clear, being transparent, that's the word. In the interest of transparency, I'm going to show you 3 websites today, and one of those websites does give just a little bit different results, and that's the annuity formula. But again, in the real world, you're not going to be worrying about that small error. The website I show you for a mortgage calculator is dead on. The website I'm going to show you for a credit card payoff calculator is dead on, which that's not even in these formulas because that's just a completely iterative process. The only way you can do that one is by hand, iteratively, which means going month to month to month until it's 0, or in Excel and going month to month to month until it's 0, but obviously that would be much quicker, and that's the way you'd want to do it. And in fact, if we still had time for this course, I would love to do a credit card payoff Excel homework assignment, but I just don't have time for that. So, all right, let's get into real world stuff. Chapter 9, notes to share. And you will notice, especially, hopefully, you've already seen this file like I've asked you 25 times because we've had about 20 classes. You're supposed to look at the next couple sections worth of notes. Chapter 9 is 9.1 through 9.5, and I believe we skipped 9.4 just because it doesn't have any real practical application for us. It's just some built-in Excel formulas that are extremely convoluted to use, and I know that no one's ever going to use them again after I teach it, so I don't. So again, you'll notice that while we're covering 9.1, 9.2, 9.3, and 9.5, I believe, those are the 4 sections, I start at 9.5. And you know why I do this? It's because I want to take a more realistic approach. This textbook starts out with your retirement formulas and your annuity formulas, and then ends with your mortgage and car payment formulas, which is also a student loan formula. But here's the thing, in the real world, that's not the order we acquire these things. So I'm going to take more of a real world approach. And admittedly, if I was going to do that, I should probably do credit cards first, but I still would rather just kind of do debt all as one blanket and do good versus bad debt. And yes, you heard me right. Good versus bad debt. There is good debt. There is, in fact, good debt. Now, you might say there is no good debt. Being in debt means you owe money, and that's bad. And I get what you're saying there. But we need to just kind of have a more focused discussion and understand when I say good debt, that I'm saying that for a reason. Good debt allows you to leverage. Leverage means all of us have a pool of money, arguably, that we can go to a bank and ask for. So you might have, say, $1,000 to your name, but you've got a job, so you've got regular income, your credit score isn't trash. You can go to a bank and say, hey, let me get $100,000 on this home I'm about to buy. So now you are able to purchase this building. Now $100,000 is a cheap home, but let's just go with it for now. You're able to purchase this home, this $100,000 building you're able to use because a bank has allowed you to, quote, leverage debt. Again, that's money that you don't have, and a bank is saying, nah, we're cool. As long as you make these regular monthly payments for 30 years, we'll take some interest off the top, and then ultimately you can have your home, and after 30 years, you don't pay us anymore, you own it, and your leverage debt is now gone. So that is actually good debt. Bad debt, spoilers, credit cards. Credit cards are awful, no good debt. Do they have their uses? Absolutely. Does your teacher love credit cards? Absolutely. They can be used for good, but they can also be used for evil, which is what the credit card companies intend them for. Now, we'll get into the pros and cons of credit cards soon. Mainly the biggest pro for having credit cards, besides perks and things like that, and establishing credit score, is that let's say you lost your job and you don't have any income for 6 months, you could put your life on a credit card and just let that stack up and then start paying it off once you got a job again. That would be a good use of bad debt, because hey, at least you still have shelter, food, electricity, all that stuff. But let me save the credit card rants and ravings and teachings for when we get there. So mortgages. So I point out there are formulas for these calculations. You've already seen the formula sheet. Again, if I don't have that already available in Canvas, I will make sure it's available today. I believe it's in the exam section, the review section. Don't quote me on that yet, but I believe that's where it will be. But you only have so many spaces besides the lecture video, so you should be able to find it easily. It'll say Math 154 formula sheet. It may even say for final exam, but I think it just says formula sheet. So again, to start discussing, we'll use online calculators. For some of these, we will use the actual formulas from the formula sheet to confirm that the online calculators work. All right. So mortgages, these are the good kind of debt. Some people would argue student loans can be good debt as well, and that car loans can also be good debt. I will say that those things are good debt as long as the APR, the annual percent rate, the interest rate, is low. Anything under 5% in our world today is a good interest rate and can mean that that is good debt. So if you get a car loan for 3%, that can be good debt, believe it or not. If you get a student loan for 4%, I'd call that good debt, especially since you're working towards a career and making some money later, hopefully, depending on what your degree is and all that stuff. Yeah, and it's one of those cases where I'd love to have a few more quips, but it's recorded and I don't want to, I don't know, I get a little scared of saying things when they're recorded, even though in my opinion, I don't think I'd be offending anybody, but I don't know. I have to manage my little quips, I guess. Okay. Yeah, I really don't think it would offend anybody. It's just about careers, and what you get degrees in. But anyways, do what you want to do. That's the ultimate point of the story. Do what you want to do. Just don't take on $200,000 worth of debt for a career where you're going to make 20 grand a year. That's basically the point I would be making with my quip. All right, so mortgages. Mortgages are a type of loan that you get on a home. So when you want a home loan, it's called a mortgage. When you get a car loan, it's not called a mortgage, it's just called an auto loan or a car loan. When you get a student loan, it's not called a mortgage, it's called a student loan. But again, they all use the same formula to calculate the interest owed, the future values, your monthly payments, anything like that. So mortgages, when you go to apply for a mortgage from a bank or wherever, whatever lender you're going to, these are typically done in 15 or 30-year installments. And every mortgage I've ever seen has been a monthly payment. But notice I said what I've seen. I'm not saying there aren't quarterly mortgages out there or semi-annually mortgages out there or daily payment mortgages out there. And in fact, some of you may be aware that you can actually pay your mortgage more often than what the interest accrues. So the interest accrues monthly. You could make your payments every 2 weeks. That's a common technique that people use to pay off their mortgage sooner, in fact, and we'll get into some of those ideas later. And I have a lot of things to discuss. I got to make sure I don't miss anything. I got to make a checklist for this at some point because it's all swimming around in my head if it's not on this piece of paper. Okay, so these are not the only mortgages offered. You might have heard of what's called a 5-year ARM. An ARM stands for adjustable rate mortgage. That's posted later in text. And in my opinion, no one should ever have an adjustable rate mortgage unless they're going to pay off their mortgage in 5 years. We'll get into that later, but there do exist these, and they call them 5-year ARMs, but it's not really a 5-year mortgage. It's a 30-year mortgage. It's just the 5-year represents when the mortgage doesn't adjust, when it doesn't vary. You want a fixed rate mortgage though, because guess what that mortgage rate does after the 5-year fixed rate's up? It goes up when it adjusts. It goes up, it goes up, it goes up, and that's what caused the housing crisis of 2008. That's it. Too many people had adjustable rate mortgages. The interest rates started jacking up higher and higher and higher. And then eventually no one could afford their loans anymore. And I don't want to say no one, a lot of people couldn't afford their loans anymore. And it caused a spiral because a lot of these pension plans and a lot of other retirement plans as well were in these what we call mortgage-backed securities. And when those were failing because people weren't paying their mortgages, retirement plans were getting crushed. And then everything just collapsed all of a sudden in 2008. Really cool movie called The Big Short. Check it out. Yeah, has everything to do with what I was just talking about there. All right, so typically 15 or 30 years, you can find a 50-year mortgage. Please don't get a 50-year mortgage unless you are just being crushed, and that's the only way you're going to be able to make your monthly payment. You are going to pay a bonkers amount of interest if you get a 50-year mortgage. Okay, so let's just stick to the two common ones, 15 and 30. Traditionally, I don't know the percentage. I'm not going to make up a statistic, but I will say most people get a 30-year loan. Most people get a 30-year loan because the longer the loan, the lower your monthly payment is. But the longer the loan, the higher your interest rate is. And these statistics are a little old. Mortgage rates have been dropping for the past year, especially the past half year, thanks to something going on, a certain virus. Mortgage rates for a 15-year, admittedly, are now like 3%. I think I've even seen some go as low as 2.75, and the 30-year mortgages are like 3.5, 3.25, 3.5. So I'm not going to adjust these numbers down here for my math problem. Just know that these payments would be just slightly higher than what they would be with 3 and 3.5. And I will on the online website show what it would be for a 3.5 ultimately, so you have a comparison. So let's find out what some mortgages would end up costing us. Now, when you buy a house, your mortgage is not your only, there we go. Mortgage is not your only payment. What most banks make you do, and again, using the word most, not all, what most banks make you do is set up an escrow account. And the word escrow means it's an account held between you and the mortgage lender, the bank, where you're going to deposit some extra money into it every month. And then at certain points, the mortgage company will withdraw from it to pay your taxes, which are typically paid quarterly, so every 3 months, and your homeowner's insurance, which is typically paid annually. Again, I'm using the words typically and mostly because there are exceptions to these rules. Some places taxes are paid, I want to say, semi-annually. It depends on the city or state you're in. I've heard of some people paying their homeowner's insurance twice a year. I personally have not seen that as an option anywhere, but again, I'm not going to claim it doesn't exist. That's not something I do. And then there's also something called PMI, which you could say is principal mortgage insurance, or private mortgage insurance is really what it is, but I always like to say principal mortgage insurance. I like to use the word principal there instead of private for one reason, because it relates to how much principal you have in your home, how much money you've actually put into the house so far. Now, if let's say you have a monthly payment of $1,000 and you've paid for 1 month, that doesn't mean you have 1 month's worth of principal in the house, because you're probably paying like $900 in interest. That means you've only got $100 paid off towards your house. You paid $900 to the bank for saying, hey, here's $100,000 or here's $200,000 or whatever. That other $100 goes towards your principal, again, the value of the house. And PMI, what PMI is an insurance that the homeowner pays, and that insurance is a policy that the bank has. So the bank takes an insurance policy out against you, but you have to pay it. Now, why does the bank do this? let's say you decide one day to stop paying for your house because you lost your job due to a virus, and the supplemental help has ended, or the virus isn't going on, and you lost your job, and it's been 2 years, and you haven't been making payments. So now now the bank's got to take your house. So the bank takes your house, it's got to sell it quick. It's got to flip it quick, or it's going to lose money. Every month that bank is sitting on your house is money they're losing. So usually they have to sell it cheap. They'll do a short sale or an auction, and they end up selling it for cheaper than what it's actually worth. Typically 20% less than the value of the home. So because they're going to probably lose 20%, let's say you move in Monday, you don't make any payments ever, and they kick you out on Wednesday. You bought a $200,000 house, and now there's still $200,000 owed on it. The bank is sitting on it, and they got to flip it. They're going to sell it for probably 20% off to flip it inside of a couple weeks, or maybe even a day. Maybe not in this market because it's a seller's market right now, but under a usual market, they're going to have to sell it cheap, which means they're going to lose money. So this PMI, this insurance, again, against you that you're paying, when you leave, they do an insurance claim, and the insurance company gives them that extra 20% of the home value to cover their losses. So if they sold that $200,000 house for $160,000, the insurance company gives them 40 grand, and they're happy. So you pay PMI until you have 20% in the principal of your home. Once you have 20% in the value of your home, again, asterisks, usually there are exceptions to this rule. Some people can get 10% versions of this because they're military or medical, or because they're a first-time home buyer, FHA or whatever. So again, exceptions to every rule. But once you have that 10 or 20% down, whatever the requirement is, you no longer pay this PMI. Now PMI, $200,000 home, probably about $100 a month, and you might as well just set that $100 on fire every month because it does you nothing. Again, it's just an extra thing that goes towards the bank. So what some people do is they say, I want to make a 20% down payment on my house to avoid PMI. The downside is a 20% down payment on, say, a $200,000 home is 40 grand. How many of us just have 40 grand lying around? So most of us usually just suck it up and pay the PMI. And in fact, if you are willing to take risk, which is the ultimate goal of this chapter's discussion, I would say don't do a 20% down payment, pay the PMI, and then take that 40 grand you might have and dump it into investments and make 7, 8, 10%, because that's going to be way more than the PMI. Anyways, finally getting to these numbers. So these are the problems at hand. Where did the numbers on the other side come from? So we're going to compare a 15-year, again, a little higher on interest rates. So these numbers are going to be a little higher than what you'd expect if you bought a home right now with good credit. Now, if you have bad credit, you're probably in these interest rates. Actually, I should say if you have mediocre credit. If you have bad credit, you might not even get a home loan, or it might be in the 5% range potentially. And they're not really giving loans to people with bad credit right now because of the financial stuff going on with the virus. You got to have pretty good credit to get a good loan right now. It's tougher. So 15-year loan, again, the shorter the loan, the lower the interest rate. So we're going to borrow $200,000 on this home for 15 years at 4.25%, and we're going to have a monthly payment. Again, on a mortgage or a car payment, if it does not say anywhere, you assume it's a monthly compounding interval and a monthly payment. And again, those two things have to be the same. So I just blanketly said it's a $1,505 payment, and then you end up having an interest of $70,900. Where did this come from? Or if you had a 30-year, slightly higher interest rate mortgage on the same amount, has a payment of $1,043 and interest of $175 and some change $1,000. Where do these numbers come from? Let's find out. So mortgagecalculator.org, this website right here, which I've already pulled up here. So this is a really cool website. And honestly, you can also just Google mortgage space calculator. And then depending on whether you have ad block or not, it might be the first, second, or third thing that pops up. Here's a much more simplified version of that mortgage calculator. Now this doesn't give us a lot of the fun options the other one has, so I'll compare and contrast them. Let's do it on the simple one first. So $200,000 with an interest rate of 4.25%. We're going for the 15-year loan first. So this is a drop-down menu. You have to just go in intervals of 5 years, whereas the other one, you can type any amount of time you want, really. And look at that. Just automatically Google has come up with a monthly payment of $1,505 and a total cost of mortgage being $270,000. If I double the mortgage to $400,000, so a nice crazy home, now our monthly payment's $3,009 and the total cost of this home to us out of pocket is $541,000. So we're borrowing $200,000 and that $200,000 loan ends up costing $541,000. Let's go back to a more reasonable home though. I'm definitely not buying some $400,000 home. Not on a teacher's salary. So $200,000 home, fairly average, maybe even median price in Hampton Roads. Virginia Beach and Chesapeake, a little higher, Portsmouth, Norfolk, a little lower, depending on the area you're in. Obviously, there's more expensive regions with Norfolk and Portsmouth and much cheaper regions as well. And the same can be said of Virginia Beach, but Virginia Beach on average is higher. So there's the 1505, and you see this number 27820. Well, that doesn't sound familiar. I remember seeing like a 70,000 number. So where are we? Here we go. I said interest of 70,900. How did I get this? Guess what I did? I subtracted the ending value and the beginning value. So hold on to that 70,900 number for a second. We borrowed 200,000. That's our starting value. We paid $270,000. This is the sum of all payments. That's where the total cost of mortgage comes from. It adds up 1505, the number of payments, times. So let me pull out a calculator to show you that that's not just nonsense. Man, time flies. All right, so 1505 a month times how many months are we paying each year? 12 months. That's our in. How many years are we paying? 15. This is just this is the payment times N times T. This right here was something we did day 1 or 2 or 3 in this course. Payment times N times T gives you total paid. $270,900. If you subtract what you borrowed, now the value of the house doesn't have to be $200,000. Maybe the value of the house is $300,000 and we made a $100,000 deposit. Maybe the value of the house was $205,000 and we made a $5,000 deposit. And there's our interest of $70,900. This is the money the bank makes for free for loaning you $200 grand. And you might go, wow, that sounds like a ton of money. Banks are terrible. I'm not going to say whether I agree or disagree with that last statement, the very last part of the statement, but honestly, they're being kind of nice. They're giving you 200 grand. Who else is going to give you $200,000? And then saying, okay, over time, over 15 years, we want a sizable amount of money, and they end up getting $70,000 and some change. But let's compare that to if this had been a 30-year loan. So again, a year ago, these interest rates were about 4.75 for a 30-year loan in good credit. Let's switch this to 30. Now watch what the cost of the mortgage and the monthly payment switched to. The monthly payments was $1,505. The total cost of the mortgage was $270,000. Drum roll, click. Our monthly payment drops from about $1,500 a month to about $1,000 a month. That's almost a $500 per month drop. And everyone's going, I want the 30-year loan. Why do you want the 30-year loan at that point? Because 1043 is significantly less than $1,505 per month. And I go, you're right, that sounds awesome. I would much rather pay $1,000 a month than $1,500 a month. But think about it carefully. You're paying $1,000 a month for 30 years versus $1,500 for 15 years. What a lot of people's instinct is that they'll say, all right, well, if it costs me $1,500 and I'm going to pay it off in 15 years, that means it's going to cost me $750 a month if I pay it off in 30 years, right? Question mark, wrong. Clearly. You know why that is? Compound interest, but that's in favor of the bank this time. So by you taking a longer loan, the bank is going to get compound interest over a longer amount of time, and that base interest is going to have more of an exploding factor, but for them. So that house that just cost you $270,000 is now going to cost you $375,000, meaning your interest is $175,000. Let me see if I can get these both on the screen in a nice, pretty way. Probably not. I just got to scroll a little bit. Well, maybe if I zoom out and scroll a little. That's not bad. Okay. So at first glance, the 15-year mortgage might seem terrible because of the monthly payment of $1,000 versus $1,500. Why would you ever want to pay the extra $462 every single month? Well, because maybe you'd rather pay $71,000 in interest to the bank versus $175,000 in interest to the bank. Now, again, this monthly payment does not include your PMI, insurances, and taxes. And on a 30-year loan, you're going to pay PMI for about 10 years if you don't do any deposit. It takes about 10 years to hit that 20% value. And again, that might not be intuitive. You might think, oh, in 10 years, I should pay 33.3% of the loan down because that's a third of the time. Nope, because of compound interest. It's going to take you a lot longer to get the remaining balance dropped significantly at first. But eventually that snowball effect starts to happen in your favor because you're going to pay more and more and more and more towards your principal versus your interest each month. And we'll see this in what we call an amortization table shortly. So again, at first glance, when you're thinking short term, I'd rather pay $1,000 a month versus $1,500 a month. No one can argue with that. But then when you think long term, you go, well, hold on. If I can pay this $1,505, notice I said if I can pay that $1,505, I'm going to save myself $100,000 in interest. So are you thinking short term or are you thinking long term? The short term person says, I'd rather pay a lower monthly payment, so I'm going with the 30-year loan. The long term person, at least for now, hint, wink, nudge, says, I'd rather pay the bank a lot less money. I don't want to give the bank my money. Forget that noise. I'd rather pay the $1,505 a month and save myself $100,000 long term. First of all, your savings would be not exactly just the difference of those two numbers, because you can claim your mortgage interest, your insurance, your taxes on your homeowner's taxes, that is, on your taxes every year to the federal government. And you'll get some of that money back. Things have changed with tax brackets lately, so this isn't going to be true anymore, but historically, you would get about 10 to 20% of your mortgage interest back in tax refunds. That's not going to be nearly as high now because tax brackets changed significantly back in, 2017 or 2018. So we have a lot larger of the standard deduction versus itemized deductions. It's not as beneficial to itemize. But either way, we're not getting into all that math. So the 15-year mortgage seems like the clear winner if you can afford the extra payment. If you can afford the extra payment. If you can't, if you've only got like $1,100, you need to take the 30-year mortgage. Now again, remember, you're still paying PMI, insurance, and taxes. PMI is going to be about $100 a month. Your insurance and taxes probably in the ballpark of $350 a month on a $200,000 home. And again, that's just guessing. Taxes vary from city to city. Portsmouth has a very, very high tax rate for reasons I won't say on a recorded lecture. But our property values are also lower, so it kind of balances. I'm sorry, my dog is doing something. I got to pause for a second, probably like 15. Okay, I'm back. Where was I? So the 100 for PMI, maybe 350 insurance and taxes. That's another $450 you're going to pay. So that 30-year mortgage is really costing you about $1,500 a month, and the 15-year mortgage is really costing you about $2,000 a month. Now again, once you've got that 20% in the home, you don't pay that 100 anymore, and that's nice. That's a small little relief. So if you're living on a budget, you go with a 30-year mortgage. If you've got lots of money just to throw at things, maybe you decide to take the 15-year mortgage. So let's go into the scenario that you've got money to blow. The 15-year mortgage seems like the clear winner if you can afford the extra payment, right? Right? Inflection in voice. And this is where I'm going to get into, are you okay with risk? Because if you are, maybe you should be taking some money and investing it, right? That's what I've tried to kind of really emphasize here and there throughout the semester. Investing is how we retire on proper funds. But investing requires risk. If you want those 8, 9, 10% returns, you've got to take risk. You've got to be willing to lose half the farm one year because 2 or 3 years later, you're going to triple the farm. And by farm, I mean your amount of money. And you're going to have scary, terrifying moments when you're younger. You're going to lose 30, 40, maybe 50%. When we went through the financial crisis in 2008, lots of people lost about half of their retirement plans. But as long as they weren't retiring in the next couple of years, they sat, they waited, they kept putting more money in. And then like 3 years later, after everything had been settled, everything was back to normal and they had what they had before, if not more money. But that's why if you are in that retirement age, if you're going to retire at 65 and you're 62, you don't have most of your money in these high risk accounts. You have a lot of money in what we call bonds and other things like that, where when the economy collapses, you don't lose half the farm in that sector. You'll still lose half of your stocks probably, depending on what your stocks are in and your mutual funds are in. But because you've got probably 70% of your money in bonds, you won't feel that pain as much and you can get past it. But if you were 62 years old and have all your money in stocks, the market might not recover by the time you want to retire. So that's why we have our risk on what we call a sliding scale. It is my opinion that most financial advisors are way too conservative with people in their 20s and even early 30s. I believe everyone in their 20s and 30s should be super aggressive. I'll even go on the record and say I don't have one penny in bonds because I want to make my money explode as much as possible, while if I do lose half of my farm, it's not a big deal because I've got some years to recover that money, explodes even more. And plus, my retirement accounts are going to be significantly smaller in my 30s than they will be in my 60s. Let's say someone in their 30s, this is not me, let's go an example. Someone in their 30s who's doing really well might have $50,000 in their retirement account, or maybe $100,000 in their retirement account. Someone in their 60s that's doing well might have $800,000, $900,000 in their account. What would you rather lose half of, 50 grand or 800 grand? I'd rather take the risk now and lose half of my theoretical that doesn't exist 50 grand. Yeah, so that's what I'm about to get into. So this is getting into the annuity side of things, these mutual funds that we've discussed lightly before. We're going to start discussing more heavily now. So first of all, before even getting into the annuity, I know I'm circling all over the place. Before we get into that complicated side of things, let's say you can't afford the $1,505 a month, but you say, well, I don't want to take this 15-year mortgage because sometimes life happens. Maybe I have a nasty fall, teacher raises his hand, and I got a lot of medical bills coming up on MRIs and x-rays and physical therapy and maybe surgeries. So maybe I don't want to be financially stressed and peak what I'm capable of paying this $1,500 every month. Let me just take the 30-year mortgage instead, and the $1,043 a month. But what you have the option of doing is saying, all right, I've got some extra funds this month. Let me put an extra $100 towards my principal. Or maybe $200, or maybe I go ahead and say, I've got an extra $462 lying around. Let me put the entirety of that into the mortgage. And what you end up doing is paying down that mortgage quicker. And if you put in $462 every month towards the principal, you're not going to pay that house down in 30 years. It's probably going to be like 16, maybe 16 and a half years. Now that's if you put the extra $462 in every month. So it's going to be like it's going to almost be like you took the 15-year mortgage. Now you might say, well, why does it take 16 years instead of 15? It's the slightly higher interest rate that causes that extra time gap. If you were to put maybe an extra $250 a month into this, you would pay that mortgage down in about 20 years instead of 30 years. So taking the 30-year mortgage, first of all, gives you the option of saying, hey, I've got extra money, I'll pay it towards the house, ultimately shortening the length of the loan, the life of the loan. And it's actually best if you can do that on the first half of the loan versus the second half of the loan, because the sooner you put in extra money, the less interest you pay over time, and that effect compounds. So putting an extra $100 towards your first monthly payment has a much more significant effect than putting an extra $100 towards the payment 3 payments before you're about to finish the loan. That honestly wouldn't even save you any interest, maybe $1, but paying $100 on your extra on your first payment might end up saving you $1,000 over the life of the loan. Okay, so that's my first suggestion as a reason to take a 30-year loan, because you can go ahead and pay the extra money like you had a 15-year loan, but if something comes up, you've got $2,000 worth of medical bills, you're not forced to do that and you won't miss a payment. Or you need to all of a sudden have a $1,500 car repair, or now you've got all of a sudden 5 years from now you get a brand new car and you get a car payment, and that some of that $462, maybe that needs to go towards your car. So it gives you some wiggle room. That's my first reason to take the 30-year over the 15-year. And I am not saying a 15-year mortgage is a bad option. If you are terrified of risk, if you just really don't trust the stock market and mutual funds and all this stuff, I can't tell you what to do, and it's risk, so I get it. I didn't like risk when I was younger. I wish I had. I wish I had enjoyed risk when I was younger. I'm a little more used to it now. Risk gives you the option to really explode your money. But again, the 15-year mortgage, still a good option if you just hate risk and you know, I've got $2,000 a month to play with before the PMI and insurance and taxes, so I'm okay handling this maybe. If that's your scenario, go for the 15-year mortgage, sure. So again, at first glance, if you can afford the extra payment, the 15-year mortgage seems like a clear winner, right? Question mark, but what if? What if analysis? What if you did something else? Let's say you take the 30-year loan. So you're going to take the 30-year loan, and instead of taking that extra $462 a month, instead of putting it towards your principal, which would be a wise investment and would save you tons of interest over time, instead of doing that and paying off your mortgage in 16 years, let's just stick to the plan. Let's pay the mortgage off in 30 years. Every single penny, that's the difference between the 15-year and the 30-year mortgage. Again, that's $462. That's the difference of these two. Let's take every single penny of that, and instead of dumping it into the house, instead of going out and buying a crazy car, all sorts of electronics every month, let's invest it wisely. Let's put it into an annuity. So mutual funds, maybe the S&P 500, maybe the Dow, maybe the NASDAQ 500, maybe some other mutual fund you like, or maybe a bunch of different mutual funds. I like a little bit of transparency. I won't give you numbers or anything like that, but I'll say I have money in lots of different mutual funds, about 10. So I don't even have money just a bunch of different stocks, because each mutual fund has anywhere from 50 to 500 stocks. Some of them even more than that. There's a mutual fund that accounts for every stock in existence in America. That's the Total Market Fund. And when I say total, the word total is misleading, but it's good enough to call it total. So you find some mutual funds you like, or maybe you find something actually called an annuity online, and they're going to give you 7%. I'll be honest, if you find something called an annuity, they're actually calling it an annuity, they're probably going to give you 4%. Annuities are generally matching pension plans, and those are both in the ballpark of 4% earnings per year, because they are very conservative, because they don't want risk. They've got to make sure they can pay you exactly the same amount every year, so they have to take less risk. There's a lot more in bonds, a lot more in international markets, and such and such and such. So your plan, your little aggressive S&P 500, that's your annuity, I'm sorry, that's your mutual fund that you chose. And historically, it's earned about 7% when adjusting for inflation. So let's assume that that's going to continue. Is that guaranteed? No. Past results do not dictate future results. But let's just use the number for the sake of it. So we're going to use this website, calculator.net/annuity calculator. Now again, the formula sheet had a formula for this. The website returns a little bit different results. And after this, I will go back to the mortgage numbers and show that those are true. Actually, I was supposed to also use the website. I got to go back to the mortgage bits after this. I get too excited. So Annuity Calculator off of calculator.net. If you just Google Annuity Calculator, this is like the 5th one that comes up probably, depending on how your ads are. Yeah, so there's a lot of different annuity calculators out there. This is my favorite. This is the one I suggest you use because annuity calculators are two-sided. There's calculators for the setup of you depositing your money and building up your wealth, but then there's also annuity calculators for when you're withdrawing your money and seeing when it will eventually run out. So starting principal of 0, annual addition, let's go 0, monthly addition. So we're taking $462 every month. So remember, we're getting the 30-year mortgage, but then we have an extra 500 and some change left over. So we take 462 of that and we say, all right, well, instead of getting the 15-year mortgage, instead of paying it like I had the 15-year mortgage, let's put it into a retirement account because that's going to be better for us probably. We assume that we're going to get 7% return. And we're going to do this for how many years? Well, it's a 30-year mortgage, right? So we're putting away $462 for 30 years, and yeah, the number's right there, but let's see it achieved in the calculator. Hit calculate. I did not change the 10 to a 30, pardon me there, but this will be cool. So after 10 years, your ending balance is $80,000, of which you put in $55,000 and $24,000 was interest. So this is going to be really cool. Right now, 10 years in, you put in 55 grand and you've got 24 grand for free. Well, that's really nice that you got 24 grand for free, but I wouldn't call that an explosion. Now let's do it for 30 years. Watch those numbers change. We've now put in 166,000 because we keep putting 462 every month in for 30 years. That's 360 times we do that. 12 times 30 is 360. That's also how many monthly mortgage payments we make, 360 monthly mortgage payments. But look at this now. Whereas before our principal was like twice our interest, now the interest is like twice the principal. It's a little more than that. We now have almost $400,000 for free. Now, if you qualify, which most of you will, this would be able to go into a Roth IRA, which would grow tax-free, which means you now have $400,000 tax-free. On top of the $166,000 you already paid your taxes on, probably. So this $543,000 should all be accounted for on tax. You can just withdraw that and take it to the bank or the store. Take it to another bank, whatever, store, buy a boat, buy a vacation, buy something nice, sit on it for 30 years, live a nice, happy life. Is that a great retirement amount? Honestly, it's a little low in my opinion, especially considering inflation that's going to happen in the next 20, 30 years. But it's a great start because this was just the difference of your mortgage. Maybe you had some other money put away. Maybe you've got a pension at work. Maybe your employer is matching 401k stuff, et cetera, et cetera, et cetera. All right, so that's where that number comes from. So look at those numbers. Ending balance of $543,000, total interest of $377,000. Total value 543, interest of $377,000. Now again, if I used those formulas, these values would be just a little different because of the way that website compounds. Again, a little different. It's not going to be like 600 or 700,000. It would probably be like 540,000 or 546,000, somewhere in that ballpark. Okay, that's really cool. So what's the benefit here? You took the 30-year mortgage. You paid the bank $175,000 in interest, but then you got $377,000 in interest. That means you just netted 200 grand. A little more than that after you consider your taxes as well, the tax write-offs you'll get. And also the 200 grand that's left, it's going to be more than that as well because of the tax-free status if you did the Roth IRA. So Person A takes the 15-year loan and ends up paying $71,000 to the bank. So there's $71,000 in the hole, essentially, outside of also purchasing a home. Let's ignore taxes. The person who got the 30-year mortgage and paid the bank $175,000 in interest overall, but was able to save the difference of these two things into a relatively average, in my opinion, a relatively average mutual fund for 30 years. And they end up, yeah, they paid the bank $175,000, but then they are $200,000 above that. That's amazing. So what if you consider these two scenarios, what would you rather do? Would you rather take the 15-year mortgage or the 30-year mortgage? I'd take the 30-year mortgage and then pay the difference for 30 years. But that's not every little detail, because guess what? If you took the 15-year mortgage, you got your house paid off in 15 years. So years 16 through 30, you are no longer making a monthly mortgage payment. So guess what you could do with that $1,500 every month for years 16 through 30? I hope you see where I'm going with this. You could deposit it into a mutual fund, earning 7% average compounding monthly interest. So here's your other option. So at first it sounded like, oh yeah, the 30-year mortgage was way better because I'm going to get that $377,000 in interest. But if you take the 15-year mortgage, at the back half, you got 15 years where you're not paying a mortgage. You just take every penny of that and dump it into a mutual fund. Maybe that could build up to the same amount. Maybe, maybe not. Let's see. Because now, instead of putting away $462 every month, we can put away an entire mortgage payment because we're not paying one penny of this $1,505 anymore. So we can put every penny of that away. Now, realistically, is someone going to do that? No. They're going to have a little fun probably. They're going to take a couple $100 of that and, you know, maybe eat better food or have a better car or take better vacations or maybe buy another house or buy a property to rent or something like that. But let's just say we're using every penny of this towards one cause. Keep it simple. So what if after paying that 15-year mortgage down, for the next 15 years, you take every single penny of the original payment, put it into that 7% S&P 500 fund? Again, not guaranteed 7%. It could be more, it could be less. The past 10 years of it, it's been 14%. I expect the next 10 years to be lower than that, but who knows? So if you put that $1,505 away for 15 years, so let's go back to the website. So now we're doing more than triple. So 500 versus 1,500 was really 462. So this is a little more than 3 times the monthly payment, but we're only going to put this away for half the amount of time. Now, we're tripling the payment, but halving the time, which means we will put more money into this account. We will put more money into this account in 15 years than the other one in 30. And look, I wasn't lying. $270,000 versus the $166,000. We've now put an extra $100,000 into this. Now you might say, oh, okay, well, that's the $100,000 you saved in interest to the bank. Well, that's a great argument, actually. I love that argument. But look at the interest. Now, instead of getting $370,000 for free, we're only getting $200,000 for free, and our ending balance is only $470,000 versus an ending balance of 500 something before. So we have less money in the retirement account. We have put more of our money towards that retirement account and gotten less interest. That is worse on all 3 of those bases. Is it bad? Absolutely not. You've still got about 50% return on your money, on your principal, which you put in over time, that is. I'm not saying average annual return, I'm saying total return. And the end of it, you still have 43% interest that you got for free. $200,000 for free is nothing to cry about, especially since most of America, more than 90% of America, doesn't come close to this. If you can do this, you're doing great. You're beating the average insanely. So putting $1,505 away monthly for 15 years, you have about $70,000 less in your extra retirement account. And of that $70,000, and after the fact that you got $70,000 less total, you also have $200,000 in interest versus the $377 in interest. So you put more into it, you got less out of it. It's still good, but the other scenario is obviously better. So again, this is all assuming you are okay with risk. Financially speaking, the person that can accept risk and ends up getting 7% return over 30 years, the best thing you can do is take the 30-year mortgage, take that extra money you have after that 30-year mortgage, dump it into a good retirement account, good mutual funds, let that grow for 30 years, and boom, you've got a ton of money. If all you're doing is just paying off your house and then you say, oh, I got extra money, I'm just going to have fun with it, you're not going to get your $500,000. Hopefully you enjoy the fun you had. Hopefully you find a way to live once you're retired. Hopefully whatever else you've done can help there, but there are not enough people being fiscally responsible, financially conservative enough to be able to survive in their old age off of something besides just Social Security and maybe a small pension or a very, very small retirement plan helped through work or something like that. And who knows what Social Security will be 30 years from now. No one expects it to be the same as now. At best, financial analysts say that we'll get 50 to 75% of what Social Security is now. But that's at best. There are people that believe it won't be here in 5, 10, maybe 15 years. I'm not saying which of those things I believe in because I don't want you to go based off of what I believe off of that, because that is widely speculative. There are tons of things that we can change over time, but there are lots of reasons that Social Security is having issues. One of them being that our population is not growing as fast as it used to. That's that whole, our population grows on an exponential model on a shorter term. You might say, Mr. Beckner, you always said it's a linear on shorter term. Yes, on the shortest term, population grows linear. On a medium term, it grows exponentially. On the long term, though, it grows logistically. We'll grow fast for a while, but eventually we slow down and kind of taper off. And we're starting to hit that tapering off. So because our young population is shrinking, there are less people to put money into Social Security, which is why there's less money for the old people to take Social Security out. This is a massive issue in China, where they had the one-child law for a very long time, which just absolutely crippled the young population in terms of size. So their Social Security system practically collapsed. And I may have talked about the cons of Social Security before. Social Security is based off of how much money you made over your life. It actually favors the rich, because if you're rich, you make a lot more. Also, statistically speaking, rich people live longer than poorer people, so they make more each payment and they get more payments. Sucks, in my opinion. It was a necessity when it was created, but it needs to be reformed at some point, in my opinion, to help the not rich a little more. The people that aren't able to do this retirement stuff or have not been educated on it. All right. Back to the actual point. 30-year retirement scenario, 30-year mortgage is better for two reasons. First, if you actually invest as stated, you will net the most money possible out of all those, assuming the market trends at 7%, accounting for inflation. You'll net more money. You have the option of not investing the extra money, on months you can't, as I mentioned earlier. Mess up your shoulder, medical bills, you've got diabetes now, and that's an extra $5,000 a year because that's a ridiculously expensive, crippling issue that people have. So maybe you don't hit your $543,000 because you miss a couple of those extra $462 payments because oh man, my taxes were ridiculous this year. I wasn't expecting to pay taxes. I got $1,000. Well, that's 2 months. Just don't throw it into the annuity. Don't throw it into the mutual fund. But ultimately, you do have to decide whether you want the risk or not. And if you're entering the workforce in what we call a bear market, where the stock market's shrinking, the economy's shrinking, and you're not making your money off your investments for a year or two, and you may be even losing half of your initial investments, it sucks because it scares you off from really hammering down on your investments. But after these bear markets, what usually happens is tons and tons of growth. We get these bull markets. Bulls charge, bears hibernate. That's the reason for bull and bear, if you weren't sure. So we get these really, really high growths because after the bear market, once things start settling down, now all these mutual funds and stocks are on sale. They're cheaper. So people go, yeah, I'll buy that thing now that it's 30% cheaper. And you get a lot of people doing that, and it causes the prices to go up quick and quick and quicker and quicker and quicker and quicker. So again, remember, all investment values are speculative and for educational purposes only. This is not financial advice. You must make your own decisions. Do not do as I say. Get a financial advisor, do your own research, check out YouTube. There are lots of people on YouTube that can help you out with this stuff and are better speakers than I am, in my opinion. You've got your Gordon, sorry, not Gordon Ramsay, your Dave Ramsey's wrong Ramsey. Gordon Ramsay's a chef. Dave Ramsey is a financial advisor. You've got a lot of younger people as well, like Andrew Zek, Graham Stephan. I mean, if you click on one person's video, you'll probably find 5 more people. I'm really trying to remember this other dude who is in Ramsey's group. I can't remember. It doesn't matter. Not the point. Okay. The other part of this whole thing is this is all based on getting a mortgage, owning your own home. Does every single one of you need or want to own your own home? Probably not. Some people are better off renting their whole life. It just depends on what your goals are, how much you're willing to put into something. But renting is an option. First of all, renting is a better option if you're only going to live somewhere for a couple of years. It usually does not become financially advisable to own a home unless you're going to be there somewhere between 5 and 9 years. A lot of people will say 7 years. Depending on how the housing market is growing, it could be as low as 5 or as high as 9 or 10 years. It can also depend on where you bought. If you bought in, say, Portsmouth, and I will fire shots this time, Portsmouth real estate has not grown in 10 years pretty much at all. Whereas if you bought, say, in Portland, Oregon, where real estate has quadrupled in 10 years, you could have sold that house 6 months later and made a profit. Portsmouth, you probably need to hold a house maybe 12, 13, 14 years to make a profit because of the lack of growth, which we won't get into why it's not growing. So if you're going to be somewhere short term, renting is probably for you. If you don't like having big expenses all of a sudden, renting is for you. Because if you own your own home, there are lots of repairs and improvements that have to be done over time. Your roof is going to last you maybe 20 to 30 years depending on the weather and the quality. Again, I like a little bit of transparency. I had to replace my roof about 4 years ago. That was 7, 8 grand, somewhere in that ballpark. I want to say $7,000 at the end of the day. If I was renting, that wasn't going to be on my dime. But because I own the home, it was on my dime. I put in some new windows, my dime. If you want to replace the carpets, you get the idea. If something breaks, your dime. Now, there are some renting situations where your landlord might not be great and you end up having to replace some things. Like if you're in an apartment, a lot of places will replace the light bulbs for you. That's kind of crazy. I mean, that's really, really nice if you just don't want to have to do anything. They'll do your AC repairs, your sink repairs, your plumbing, whatever. Find a good place that actually keeps up with that stuff and doesn't make you wait a month. But again, if you own, you're going to pay for all of that stuff. Now, in your rent, some of those things are accounted for, but you're paying that on a monthly basis instead of all of a sudden, boom, $7,000 expense. And if you don't have that $7,000 in the bank, you're going to have to go get a loan or put it on a credit card or something like that, or maybe borrow from your investments, which is not something I generally advise, but that's up to you. And again, when I say generally advised, I'm talking outside of class. I do talk a lot about this stuff outside of class, friends and family. It's one of my favorite topics. I really like to give people advice. This isn't just something I do because somebody's paying me. I love this stuff. I love giving people financial education to help them not pay, quote, the man too much and to ultimately be able to retire. You go to sell your home. Oh, foundation's cracked and slanted. So that's $10,000 repair, $20,000 repair. That happened to a neighbor of mine. She wouldn't have had that expense if she was renting. Now, here's the thing. You might say, well, why would anyone ever want to own their home? Well, homes go up in value over time, typically speaking, depending on location, lots of things involved with that variance, how much money you put into it, how well you keep it up. But the mortgage, after 30 years, you're done. All you're going to pay is your taxes and your insurance. Again, $350 a month roughly on a 200-grand house in Portsmouth, in P-Town. 350 bucks a month sounds easy to pay. All of a sudden, as long as you are budgeting, like your QR teacher has suggested that you do, and you put money away, okay, well, I know in 30 years I'm going to need a new roof. Last time, let's say it's going to cost me 10 grand. I'm going to take that 10 grand and divide it monthly. And if you did that, that's 27 bucks a month, 28 bucks a month. So someone who considers that is taking $28 a month, sitting it somewhere in a savings account, into a mutual fund, stocks, bonds, whatever, just sitting on it somewhere. And every month, 28 bucks is going into this account, or even a theoretical account. Maybe it's just on an Excel spreadsheet somewhere you have that, oh, hey, my roof budget is this. And then 30 years from now, first of all, if you're putting that into a mutual fund, that money is growing and you'll have more than the cost of the roof. But at least if you put it into some savings account or put it under your mattress or something, after 30 years, you have the amount of money to pay for your roof. Boom, no loan, no credit card debt, no crying. The same thing goes for cars. You can say, oh, I need to buy a new car every 15 years maybe. Take that cost, divide it by 15, divide it by 12, and you have your monthly payment that needs to go towards a new car. Now, you'll also have monthly amounts of dollars that needs to go towards your insurance, your repairs, your fuel, all sorts of things. All right, before we move on to credit cards, let's go back to the mortgages. Let's go back to the annuity calculations. Let's show first how these mortgages would have been seen in the mortgagecalculator.org website, which is here. So this wasn't as simple. There's a lot more little boxes. You can actually use this to throw in, if you know how much your property tax costs every year, if you know what your PMI is as a percentage of the value, what your homeowner's insurance is, HOA if you've got it, loan type, you can put that in there. I just stick with conventional for these calculations. So let's just make the home value exactly what the loan amount is. So home value is 200 grand, down payment of nothing. And you could also say the home value was 250,000 and your down payment was 50 grand. That still says your loan is $200,000. It doesn't matter. It's just the difference of these two things is your loan. Interest rate, let's do the 30-year one because this one's going to be a little more relevant. So the 4.75, again, these are year-old values. Forgive me there. Loan term, 30 years. Let's say it's starting right now, and let's just focus on the principal and the interest. So property tax 0, PMI 0, home insurance 0. I'm also going to click this button down here. You don't have to. I could just go ahead and hit calculate, and it gives me this graph of balances, which might confuse you. It's a lot going on at once. This right here is the balance of the loan, and you can see it's a curve. It's not a line. It doesn't just go straight down over time because of the way interest compounds. You're going to pay a lot more towards interest than towards your principal at first. But over time, you get that snowball effect, and you'll be paying more towards your principal, and the balance drops quicker and quicker. The light blue and dark blue, you can see are the interest and principal. So in the first year, you see the light blue is a lot bigger of a chunk than the dark blue. So this chunk right here is what you pay towards interest, which is $9,300, as you can see. And this is really like year half to 1.5 because of the date we started on. Let's just say we start in January of 2021. No numbers will change. Oh, wrong button. Not compare loan types. Calculate. I'm not used to that button being there because I have ad block on my normal computer. This is a barred computer if I haven't said that before. Obviously, I'm not Jen, as you've probably seen that pop up before. So again, none of these numbers over here will have changed. It's just this thing. So now we have a true accurate 1 year, first year representation. So the interest you pay over the first year, so here's your mortgage payment of $10.43 a month. Now this website actually gives you the pennies as well, which makes this number possibly off by a couple of dollars because of the extra pennies here. And when you pay a monthly mortgage payment, you'll pay cents. But for our homework, for the main issues of the course, we round these to the nearest dollar just to keep the math simpler. So anyways, first year, paying that $10.43 a month for 12 months. $9,400 of that goes towards interest. That's the bank. That's their free money for loaning you. And then $3,000 of that is towards your principal, which reduces the balance. Again, the principal is what reduces your balance. So if you subtract $200,000 and that $3,086, you come up with the $196,913 and some change. Your interest is always based off the balance. So when you make your first payment in the next year, your interest is calculated based on that $196,900. That first year, you've only paid $3,000 of your house down. Let's look about halfway through. Now your interest is $6,500 that year, and $6,000 is going towards principal, and your balance is now only $134,000. Let's look another year in. Now our balance is only $127,000, $121,000, $114,000. Now our balance is going down by about $7,000 every year, $107,000, about $100,000. Then it goes down by about $8,000 every year. Then eventually by about $9,000 every year, and about $10,000 every year, until eventually the balance hits zero. Look at this last year. You only pay $300 in interest. The bank hardly makes anything off of you that last year, but the principal, the amount you pay towards your loan, is $12,000. So our balance was $12,000 and some change at the end of the next to last year, and now it's zero. Look at the difference of the interest versus principal payments last year versus first year. The last year, you barely even pay principal because your balance is very, 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 very low. But over here in that first year, you're paying way more interest because your balance is very, very high. So again, this website gives you your monthly payment. Boom, accurate. The down payment, if we typed it, is there, and I just left it with a scenario where we paid a down payment. Total interest paid. Well, that's the same number we calculated before, basically. Again, it might be off by a couple of dollars. $175,586. What do we have here? $175,586. Actually, it's accurate. Just has the extra 0.08. The total we paid of 360 payments, $375,586. So now when I hit calculate, I'm also going to hit show amortization tables. Amortization table. This is going to show us a month-by-month breakdown, or year-by-year if you do it that way. A month-by-month breakdown of what money is going towards principal and what money is going towards interest, and then what the balance is. So when I click this, the draw charts part I don't really need. Let's just show the monthly amortization. This will be a giant chart. The annual one will be much smaller. Calculate. So here's your monthly amortization schedule. When you get a mortgage, the bank prints this out for you. So January, first month, you pay about $800 in interest and $250 towards principal. Again, principal reduces your balance. So you subtract to find your new balance. 200,000 minus 251.63 gives us this new balance. Now the ending balance in this month is the starting balance in the next month. And then they calculate your interest. Where does this 791 or 790 come from? Remember, when you're looking at the smallest scale, interest is just the product of the balance and the periodic rate. Remember, on the smallest scale, when you're looking, if you're compounding monthly, when you're looking at 1 month, or when you're compounding daily, when you're looking at 1 day, the interest is the product of balance and I just lost the term, and I said it a minute ago, the rate, not the annual rate, the monthly rate or whatever. Either way, you know what I meant. I said it a minute ago. Sorry, I'm blanking on that term all of a sudden. I got too many thoughts. So if I pull up my calculator, if I just take $200,000, the periodic rate, there we go, periodic rate, and we multiply by the periodic rate. Now remember, the periodic rate is the APR divided by N. The APR was 4.75. As a decimal, that's 0.0475, just moving the decimal left twice. But then I have to divide it by 12 because we're compounding monthly. Again, this right here is the periodic rate. This right here is the balance. Balance times periodic rate, interest, 791.67. There it is. Then in the second month, our balances dropped to 199,000 some change. So 199,748.37 times that same 0.0475 divided by 12. There's our amount of interest we pay in the second month, 790.67. It dropped by $1. And then it drops by another $1, and then another $1, another $1. And every time the interest drops by $1, the principal goes up by $1. Now, it's not exactly $1 every single time, because look, here, that's not $1, that's $1.02. Then down here, it's $1.07. So the drop increases as time goes on. Let's go to the near end of it. And here, the interest drops by about $3. So our interest is decreasing quicker and quicker over time. That's that compounding effect. Let's look at our balance. So again, after 1 year, January 2022, well, I guess December 2021, that's our 12 months, we've only paid $3,000 of this down. In the next year, we'll pay about $3,300 down. And then the next year, we pay about, what, $3,400 down, something like that. Each year we pay a little more and a little more and a little more down because the principal is growing. Each month the interest shrinks, each month the interest grows. So we started this in January of 2021, so halfway through would be January 2026. And again, you might think we'll have half the balance left, only $100,000, but check it out. January of, I think I said 26, I meant 36. So January of 36, well, December technically, we're at 134,000. That's not halfway down. You'd have to have paid off another $34,000 for that to be halfway down. But go another 5 years, so now let's go to 41. Now we're halfway down. It takes 20 years to pay half your mortgage. It takes 20 years to pay off half your mortgage, but then the last 10 years, you'll end up paying the other half because of snowballing, because of the compounding effect. Remember I said earlier, if you make no down payment, it takes you about 10 years to hit that 20% of principal. That can be seen here. Now, I know in the problem I put a down payment. Let's just say we bought a $200,000 home with no down payment. Some people can get that type of loan. So 20% of 200,000 is 40,000, which means we're looking for $166,000 balance. I mean, 160,000, excuse me. Here we go, 160,000 happens in year 2031, which is 10 years later. It's like 10 years and 2 or 3 months that we actually hit 20%. All right, so that's the Mortgage Calculator website, one of my favorite calculator websites, in addition to the Annuity Calculator, which we demonstrated as well a couple of times. I love this breakdown pie chart because that really shows you how much interest you have. So the 1505 over 15 years, the dark blue chunk was smaller than when we did the 462 for 30 years. Look at that. Boom. Bigger blue chunk because more time. More time means more interest, more explosion. Okay, you might say, well, I'm a good investor. I know I'm going to be able to get 10%. This is what I expect. And you can have fun with this website. You can just see what you might be able to net over time. So if we are able to research, do good, the markets are good, we make good mutual fund decisions, whatever, and we get a 10% average return adjusted for inflation. Instead of having $543,000, we would now have $960,000. We've almost doubled how much money we have. Now, the principal has not changed. We did not put one extra penny in it, but by doing research and learning this stuff, or maybe just hiring a good financial advisor, whatever, or maybe just the market happening to be good, you almost end up doubling your money just by getting an extra 3%. Now look at this pie chart. It's almost all interest. It's 83% interest. Look at your explosion. And this shows all three things. The green one is your balance. That's the most relevant. But look, the principal barely grows over time, but that interest after the 15-year mark starts exploding. 15 years is not enough time to make your money explode unless you have really high interest rates. Now, sure, that 1505, again, we're just having fun here. Maybe you knock it out of the park and you get an average annual return of 15% adjusted for inflation. Again, this is insane. So 15 years, you paid off your mortgage, you got 15 years of not paying a mortgage. I mean, you have the rest of your life to not pay the mortgage, but let's just say once your mortgage was done, that's when you planned on retiring. And if it wasn't when you planned on retiring, maybe you got another 10 years to keep adding to that pile and just become stinking rich. All right, so somebody just knocks it out of the park, 15 years of 15%, $927,000, a lot better than the like 400 we had before. But again, I can't promise you any of these numbers. I can't promise you that. No one can. You've got to be willing to take the risk and hope for them. And again, most people aim for this. You hope you get something like this, and maybe you just really learn this stuff, or maybe you get good luck, and maybe you get this. I have a friend who is just all about this stuff, and he gets like 30% annual return every single year, pretty much. Last year, he got 50% return. Me, I'm not that good. He does all the crazy stuff like shorting stocks and options and blah, blah, blah. I know a little bit about that. I'm doing my own learning right now on it, but I feel like I need a lot of time to learn before I'm really willing to commit to this much more risky operation. And that is not something I'm advising anyone to do. Buy and hold is what you do when you're not just going to do this with passion and focus. Buy and hold. When the market drops, most people would say buy and hold. Just take the hit temporarily, because 5 years from now, it'll be back to where it was, if not higher. And that's if it even takes 5 years. And sometimes it's taken 5 years, sometimes it's taken 3 years. There was a period of time where it took 10 years to recover. But again, if you're not retiring for 20 years, that 10-year recovery doesn't matter. Because again, at the end of the recovery period, we have always, and again, not promising it always happens, but we have always seen large growth after that. What do I need to do next? We practiced with the Mortgage Calculator website. We practiced with the Annuity Calculator website. It's 10:15. I just feel like I've missed something. Oh, I wanted to do the annuity, show you the difference there. So we said 462 with the formulas. Yeah, let's do the formulas. So let's pull this to the side. Let's put the formula sheet up here on the other side. Let's get our calculator. So let's do the loan payment one first. Let's do one of the mortgages. Let's do the 30-year mortgage calculation. So 30 years is the time. That's T. 4.75% is our R. $200,000 is the P. That's the principal. And then we want to find a payment. So that's the R. So the 30 was the T. 4.75 is the APR, which is R. The 200,000 is the P, and we're doing monthly payments. Oops, no equals. So 12 is our N. Those are the four numbers. I'm going to plug into this, oops, this formula right here. So what that's going to look like, ooh, that's weird. When you plug it into the formula, this payment formula, this is a loan. So we get payment equals P, which is $200,000, times R over N, which is 0.0475 divided by 12, close it, then divided by, bracket, parentheses, sorry, I did that wrong, I'm looking at the wrong one, bracket 1 minus, parentheses 1 plus. This is one of the more unique formulas because of this part being second and the negative exponent. You don't have to memorize it, you just have to know how to use it. Plus R over N, that's the same 0.0475 divided by 12, close the parentheses, then raise it to the negative NT. N is 12, T is 30 because it's a 30-year mortgage. Now, please note in the calculator, 12 times 30 is 360, so that's negative 360 when I put it in the calculator. I just don't want to rewrite all that jazz. And then don't forget to close your bracket. Calculator. Clear. 200,000 times 0.0475 divided by 12. Close the parentheses. Divided by. Now, there is no bracket button in most calculators. You might say, yes, there is. It's right here. Brackets in calculators are generally used to represent what we call a matrix or matrices. It's not the same thing. If I do this and then start typing numbers, it's going to give me an error because that's not really a bracket. So you have to do parentheses in your calculators, unless you have some super crazy calculator. I can't speak for everything. All right, 1 minus parentheses 1 plus 0.0475 divided by 12, close. Raise it to the negative 360. Now again, in your calculator, lots of things vary with how I have this. You may have to put the times before this parentheses right here. You may have to hit the negative after you type the 365. But then I'm going to close the bracket, which is really another parentheses, and hit enter. Uh, 365. Why did I type 365? I was like, something's wrong with this. That's 360. Please forgive me. Let me clear my screen. I did not mean to have 365. I think I had one of these 5s in my head when I did that. And you get 1043.29, the same that we found on the 2 websites. Again, Google didn't give us the pennies, but the mortgagecalculator.org did give us the pennies. And do I still have that up there? Yep, 1043.29. 1043.29. So you go, Mr. Beckner, why would you ever make me use this formula? Because that's what people had to do back in the day before websites. You know what people had to do back in the day before calculators? This sucked. There are worse words than suck, but I mean, I can't use a nice word for this. Math sucked before calculators. It was extremely difficult. It required these massive charts of numbers to be able to complete. You don't want to have to mess with that. So again, your homework and your test, you're supposed to be using these formulas. But when you're outside of this class, 5 years from now, 2 months from now, 30 years from now, please know that there are websites, so you don't have to memorize these formulas. You do need to know how to use them for the class. You're not going to get away from that. But when you're in the real world, you're not stuck to some crazy formulas. So the 15-year, hopefully you trust me that that would work as well. There are ways to have typed this in, just a couple bits, hit enter, write a number down, type a couple bits, hit enter, write a number down. I don't have time to explain all of that. I hope that you all have at least a scientific calculator that you're able to do this all at once, because you are able to do this all at once. You got to set up everything as it's stated. These formulas are actually written to benefit you in real math. I don't want to say that. In like an algebra or calculus class, this bottom formula wouldn't have a bracket. You'd have to know to put it there. And in fact, the old edition of the textbook also didn't have the brackets. So I was doing students a favor by putting that bracket in there. All right, so we know that this formula works, the monthly payment for a loan. What about these annuity formulas? So let's go down to the what if you invested blah, blah, blah. Now remember, I mentioned these annuity formulas are a tiny bit different, just a tiny bit, than the website. So the mortgage calculator is perfect. Credit calculators are perfect. Annuities, there's some, okay, does the interest accrue at the beginning or the end? Is the deposit being put in at the beginning or end of each month? That little variability is what changes the website versus what we do. So we have some assumptions made for these formulas that the website doesn't make. They switch assumptions. So that's why you're going to see a slightly different number, but close, but close. So we're going to put $462 away every month. So we're compounding monthly and we're depositing monthly into a 7% account. So when we do that, so our payment, this is not a P, this is a payment because we are not doing this one time, we're doing it multiple times. Something being done multiple times we call payment, not P, whether it's a payment on a loan or a payment towards an annuity. Our interest rate is going to be 0.07. Our amount of time we said is 30 years. This was the 462 being done parallel to the mortgage. And then the N, we're still compounding monthly. I will never give you a mortgage or loan or annuity. I don't want to say the last part. I will never give you a mortgage or car payment or loan where we're not compounding monthly. That's just how loans are done traditionally. Annuities admittedly compound daily, but we usually do monthly because we usually deposit monthly. And again, those intervals have to be the same. So we're going to jam these 4 numbers into which formula? There's 8 formulas. Well, it's not a loan, so definitely not the last one. We're not talking about APY, so it's not that one. Maybe it's one of these 3 things. I mean, here's an R and a T and an N, so maybe it's one of these 2 things. Well, we definitely wouldn't want this one. I'm sorry, we definitely wouldn't want this one because we know the principal, arguably. We're trying to find the ending value. So you might think it's this one, and if you think it's this one, you're wrong, because this is for a one-time deposit. P stands for one-time deposit. PMT is multiple deposits. So it's one of these 3. Okay, well, which one of these 3? Well, we can't use the top one because we're compounding monthly. The N is 12. Compounding monthly, the N is not 1, it's 12. Compounding annually is 1, not 12. Annually is 1, monthly is 12. Get that straight. I see half my students get that wrong on tests, and that's not an exaggeration. So, okay, well, which one of these formulas do we need then? This has got N's, this has got M's. This one is to find the value of an annuity. This one's to find the payment needed to achieve a goal. Well, this payment is by itself, that's supposed to be the unknown. We know the payment, so it ain't this formula, it's this one, because we're compounding in times and we're trying to find the future value. So A equals 462 bracket parentheses 1 plus 0.07 over 12. If I'm going too fast, go to YouTube and slow the video down. Raise that to the NT, which is 12 times 30. Again, I will go ahead and multiply that ahead of time. Minus 1, close the bracket, all over. And again, I'm looking at this formula and writing things down. Look at the formula, write the next thing down. Don't try and absorb this whole thing at once. Look at one bit, write it down. Look at the next bit, write it down. Look at the next bit, write it down. Take your time. Divided by the same R over N, which is 0.07 over 12. So that 12 times 30 is, once again, 360. So just note that in the calculator, you won't see 12 times 30, you'll see 360. Let's clear our screen. Okay, so 462, bracket parentheses, 1 plus R over N, which is 0.07 divided by 12. Close the parentheses, exponent 360. Again, your exponent button might be an X and then a Y that's up and smaller. So there's my 360, then the minus 1. Don't forget the bracket, which is a parentheses here, then divided by, open a parentheses. Now we're on the bottom, 0.07 divided by 12. Close it. Drum roll. $563,626.60. Let's go to the website. Annuity Calculator. Let's go back to the 462 a month, 7%, 30 years, 543,341, whereas we came up with 563,626. So it's actually a little further off than I remembered. It's off by 20 grand, but again, no one is going to be sad about that. So the reason is, once again, and I'll be a little more specific now, our formula assumes that we're putting the deposit in at the beginning of the month and the interest is accruing at the end of the month. Whereas the website, I believe, they are assuming that we're adding it at the end of each month and the interest accrues at the end of each month, which means we're always a month behind on interest, and that ends up costing $200,000. Now, which of these is going to happen? It depends on when you deposit your money. If you were, say, accruing interest at the end of every month, if you put your money in at the beginning, it's going to look more like this 563 at the end. If you were putting it at the end, it's going to look more like the 543. But again, the point is, no one's going to be sad over having $550,000 plus or minus 10 grand. You get the point. So again, this website is very difficult to be accurate, especially considering that A, your returns are unpredictable. B, they're daily, not monthly. And C, when you're doing this, when you deposit your money, maybe sometimes you put it in the beginning, maybe sometimes you put it in the end, maybe you're always consistent. What some people have to do for this, and this will be the last thing I mention in our class, some people just have this type of thing taken from their paycheck because they know if it hits their checking account, they're going to spend it on whatever, and it's never going to go into an investment. I would say more than 75% of America probably needs to be doing that if they aren't already. Just having the money taken away. That way, the first thing you are doing with your money is you're putting it towards you, towards your future. Again, I'm not telling you to do that. I'm saying it might be a good idea. Maybe start small and increase that money that gets withdrawn over time. Some people just have better reservations with their money than others, and I can't speak to anybody individually about how you are or not, nor do I want to have to invade your privacy like that. So if you know that you're capable of getting your paycheck, plopping into your savings account, and then taking your 100 or 200 or 500 or however many dollars and throwing it to your retirement accounts, if you can manually do that, then go that way. But if you know you lack control, if you lack the ability to do that before everything else, maybe you should have it pulled from your check. Now, the last thing I want to mention before we go, and we'll talk credit cards and other stuff next time, is say that, again, good debt, mortgages, maybe student loans, maybe car loans, as long as they're under a certain percentage, my opinion, and that's an opinion, is 5 or 6%, is where good debt starts becoming bad debt. There's no credit card in existence that's good debt unless you're in that first year of interest-free. If you get a special offer or something like that, 0% is fine. But most credit cards, 18 to 24%. That's terrible. That is just awful. I've seen student loans, 10, 12, 13%. That is awful. Pay those off as soon as you can. Point being, if you expect your retirement accounts to earn you 7% and your credit card's 15%, you should, in reality, to optimize your results, pay off the credit card before you start putting into your retirements. However, if you're working on it and you still think, I need to go ahead and start this now or I'm never going to, I'm not going to tell someone not to go ahead and start putting towards retirement while they're paying their credit cards off. But the first thing any American should ever be focusing on is getting their credit card debt down to $0 and then never having it again if they don't have to. Unfortunately, America has on average about $10,000 worth of credit card debt per person. And that sucks, because that's a lot of money. It goes to the banks every year that doesn't really benefit you. At least when you take that $200,000 loan and you're paying the bank money, at least you're getting a roof. Credit cards, you're paying way, 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 way more money towards them, and the thing that you're getting isn't nearly as valuable. They're important things potentially, maybe, but that's not guaranteed. All right, so need to call it a day there. That is time. So we'll pick up with credit cards next time, as well as whatever else we can cover. And yeah, so again, last second to catch any due dates, any expectations coming up. We only have one more meeting together. One more meeting together. So next Tuesday we meet. Next Thursday, the 30th, we do not meet. That will be testing day. I don't want to take 2 hours of your time if it's the only 2 hours of the day you have. All right, so email me if you have any questions. Get to work over the weekend. Please start studying. Again, the last half of the final exam review will be available soon. You can see that there. The next discussion board, sometime today, this evening probably, if I can't get it done before my next class, I'm going to have some general finance questions relating to some of what we just discussed, as well as some of what we'll discuss next time. So we'll see what your opinions might be. I really want to see participation in this one. I have seen the participation drop heavily on the discussion boards. I'm giving you some slack. I've had a lot of times where I wanted to talk to people over this, but it's a weird semester for everybody, I know. So I'm taking it easy in a lot of ways. All right, you know your expectations. Hit me up over the weekend if you need anything. We'll see you on Tuesday if not. Take care.